So let's go ahead and get started. In I Am The Cavalry track, A Good Day to Die, IoT End of Life with Jessica Wilkerson, Allan Friedman, Karl Grindal, Karim Farhat, and Ishan Mehta. That's for him.
I'm going to use it because I don't feel like putting on the other mic. Hi, everyone. As probably the only female on this panel, I think it's probably obvious that I am Jessica. I work for Congress. I am an oversight and investigation staffer with the Committee on Energy and Commerce, which essentially means that I don't legislate, but I investigate things, and it's very fun. So I'm here specifically to talk about something that my committee recently did. We have been focused a lot on healthcare cybersecurity, and so what we did a couple months ago, I think at the beginning of April, around then, we put out what we call a request for information, an RFI. We essentially said, hey, everyone, we don't know how to solve the legacy technology problem in healthcare, but maybe you do. So write in and tell us how you think we should solve it. It was open to the public. Anyone could respond. And, you know, we'll see what we can see. We'll see if there's anything coming out of that. And in this RFI, we got all the responses back. There wasn't a whole lot of consensus. In fact, I don't think anybody actually agreed with anybody on almost anything. Beyond the fact that coordinated disclosure is good, so congratulations, everyone, and specifically congratulations to Josh Corman, Bo Woods, Katie Masuris, a lot of the ambassadors over the years who've really pushed that policy. And without them, they would not, we would not be in the place for everyone to sort of agree that coordinated disclosure is good. Software bill of materials, which everyone should go follow Allan over to wherever Black Hat's being held and talk about his panel.
You guys get it for free in like 20 minutes.
Yeah. the SBOM panel there, everyone sort of said software bill of materials is great and we should do that. But beyond those two things, nobody could agree on anything. Nobody could agree on what it means to be legacy. Nobody could agree on what you should do with it. Nobody could agree on whether or not things should be supported until they're completely out of existence. You know, if a really old piece of technology is still being used in a hospital, does that mean that the manufacturer has to support it? Or if it's 20, 30 years later and the manufacturer never meant for that thing to be in existence for that long, does that mean that they don't have to worry about it anymore? So one of the reasons why this is so critically important to us, to Congress, to my committee in particular, we have jurisdiction over healthcare. It is one of our jobs to pass laws that deal with healthcare, that help make it better, that help protect patients, whatever the case may be. One of our biggest components of my committee is healthcare and healthcare law. And I think over the past couple of years, as it's become really clear, the healthcare sector is not particularly prepared for cybersecurity incidents. You've got a lot of people in the healthcare sector who still don't understand fully what it means for their sector to be as connected as it is. You know, they know that their devices, or actually in some cases I don't think they know that their medical devices are connected to the internet. But even in the cases where they do, they don't fully understand what that means. That's how we wound up with WannaCry in a lot of cases. That's how we wound up with NotPetya. It's how we wound up with in a lot of the situations that we've ended up in. And I think what we have started to see from a policy perspective is this is no longer an IT problem, right? I mean, I think this is probably something that all of you have run into at one point or another, where cybersecurity is the IT director's issue. You know, turn it off and back on again. Let's call somebody. Maybe they can fix the printer. All of it still gets kind of looped into that bucket, and nobody really thinks of it as at a grand strategic level. And so we have been trying to change that conversation to a certain extent, but it's been difficult, right? Because, again, what does it mean for something to be end of life? What does it mean for something to be legacy? And so in doing this RFI and trying to solicit comment and trying to figure out how we approach this issue, I think the only thing that we have determined is that there is still much to be determined. I know some of the folks on the panel here are going to talk about various issues, but I can say from the congressional perspective, from my committee perspective, we still don't know what to do. We don't know whether or not there should be guaranteed lifetimes for some of these devices. You know, Microsoft has their habit of, we'll support this OS for 5 years, and then you can negotiate with us for longer support. We don't know if there should be a cutoff point of when you can no longer use technology in a given environment. We don't know any of it. Registries, all of these things that a lot of these guys are going to talk about, I think so much of this is still so new and so unexplored that we want to be really careful about what Congress does, because Congress, in my committee, we have a lot of outsized influence. I think I told somebody recently that we're akin to an elephant in a china shop. Not even a bull. I think we can actually say that we're an elephant. If we pass a law, if we do something and we don't fully understand the consequences of it, we can cause a lot of damage. And so I think what we are desperately trying to do is make sure that we fully understand the problem set before doing anything, because we don't want to break anything. We don't want to make your life harder. I assume many of you are information security professionals. Some of you may even work in healthcare, and the last thing I want to do is add something else to the HIPAA checklist, or add something else. Yes, the HIPAA checklist is something that we talk about quite a bit in healthcare, cyber, even though I really wish it wasn't. But my goal, my committee's goal is don't make your life more difficult. And in fact, to this extent possible, it's have you tell me what I can do to make your life easier. And so I think that's one of the reasons why I'm really happy to be here. I have been over at the public grounds room that they were mentioning over at the Platinum Hotel, trying to give people the opportunity to ask me questions and figure out how to get involved with us. One of the reasons why I'm very interested to see what the other panelists have to say, because I think we understand that this is a serious problem, but we also understand that trying to do something before we understand what that might mean could have some serious consequences. And so if I can just put in a plug at the end of this, the legacy technology one is one that we're going to be struggling with for a long time, and I need your help. So if you have thoughts on how to fix that, please come help me help you, and help me figure out what to do about it without causing any issues. So actually I think that's where I'll wrap it up and turn it over to you.
Sweet. All right. You guys going to introduce yourselves?
Yeah.
All right, so should I go ahead? Yeah.
I'm going to go sit in the audience so I can actually see you.
All right, everybody. Is this working? All right, so we are a team from Georgia Tech's School of Public Policy. Karl and Karim are still PhD students there. I got my master and got out. Now I work in DC, and we've been working in this area for okay, better? And we've been working on this project for a few months now. Just to outline our presentation today, we're going to be presenting two slightly related projects which we've been working on. First, I'm going to do a introduction of what the IoT security problem looks like. Karl will describe the first project, which is a standards mapping. It's a continuation of the work Nist, a federal agency, did, and he's going to describe what the next steps on that look like. I'm going to then come in and talk about the collective action problem. I'll explain what that means, why it's a problem for IoT, and Karim is going to look at the possibility of a registry as one of the alternatives to solving this issue. So very quickly, IoT, I mean, a lot of you have already heard about this, but it's been bad IoT. There's a sort of hullabaloo in the media about this. You're stealing your credentials, vacuum cleaners are spying on you with your webcams, washing machines are stealing computer files, and our fridges are killing people. So, but I think I really like the subtext to this headline, which is that lack of clear and transparent policies about software updates make these devices extremely dangerous. And regardless of the headline, that is exactly the point. But the issue with IoT is that it isn't one thing. And so the definition listed up here is what the IETF, which is not to go into details, but it's a technical body that makes definitions and protocols about things, and they're you can't get broader. Constrained node in a possibly constrained network, and in these sort of very different domains, people club everything to IoT and come up with these astounding numbers. So Ericsson has a figure out there that there are supposed to be 30 billion or 50 billion IoT devices in the next 5 years. The one I put in here is what I think really explains to us is that there are more IoT devices out in the wild than there are mobile phones. And imagine the conversations we have around security of mobile phones and compared that to what we have around IoT. And so why IoT security? Like I talked about this, there's asymmetrical security between different devices, different domains, healthcare, construction, ICS machines, just day-to-day home Roombas and whatnot. There are these other attack vectors because IoT is more cyber-physical than any other, traditional computing mechanism we have out there. And end of life is, of course, a big issue with IoT. Right now, you don't have all developers and deployers wanting to support devices after, the initial software update. So Karl is going to take over and talk about standards.
Yeah, so in trying to understand the landscape in this space, you can use sort of a sectoral model. What are these sectors? But then you can also sort of look at the standards that are being formed. And I'm sort of using that term broadly because the National Institute of Standards and Technology also uses it pretty broadly. So I sort of see there as being these two subcategories of things that authorities are trying to use to grapple around the problem. You've got protocols on the one hand, a way to set certain rules for endpoints and telecommunication connections versus security controls on the other. Security controls being those guidelines, requirements that you may or may not be required to implement within your company. And the reason I don't believe that those necessarily overlap is good rules are often technology neutral, so that you're not needing to update them as the technology changes. So there was a large project that many of you might be familiar with called the Nist Cybersecurity Framework. Started in 2014, was just revised in 2018. And the goal of this government agency was to bring together private sector groups and basically say, you've got SANS 20 on the one hand, which is too short. And then NIST 853 with hundreds and hundreds of standards on the other hand, and then say maybe if we picked something in the middle, people would be able to wrap their minds around it. And so they came up with a list of recommendations. And an example here is if you go to the appendix in this framework report, you get recovery plans and corporate lessons learned after an incident. So that seems very sensible. You could do that. But then they also did something really nice and useful, which is they mapped that recommendation to a bunch of other standards, COBIT, ISA, ISO. And so these are different organizations, either governmental or non-governmental, that produce these kinds of rules and regulations. And while rules and regulations are boring, if you want to change a whole sector, compliance matters. So the NIST framework dealt with network security, but now we're in a world of IoT security, and the question is, what's different? NIST started this second project focused on the status of international cybersecurity standardization for the Internet of Things. And I think they kind of equated two different forms of standards. They had protocols on the one hand, secure communications, and they had requirements and guidelines on the other. They pulled them all together, and they basically just started listing standards, which I thought was really useful, because if they hadn't done it, I would have wanted to. And so when I found this long NIST report called NIST IR for Interagency Report 82,000, it has a long appendix with a couple hundred standards that have been implemented in the IoT space. And so I think it helps to sort of wrap your mind around how this is a large space with lots of actors, and there's really no, one dominant player. So this is the standards that they listed, ranked by their frequency, the number of standards listed in the appendix. You've got some larger players. ISO is the International Standards Organization. IEEE, you all should know, and the IETF, the Internet Engineering Task Force. Those are some larger international organizations. But then you've got a ton of commercial collaboration, these non-commercial groups, either professional associations or business consortiums, that are all releasing standards and fighting to get some type of adoption. And then they group these by core areas. And so you can see that there are a ton of standards in the cryptographic space, a lot in network security, and not as many were recorded in the security automation space. Not as many were released in the supply chain risk management space. But just counting standards isn't really a measure of quality, and so they added additional language, this maturity thing. So an approved specification was one. They would also list, market adoption, or is the standard under revision? Is the standard currently being drafted? And I thought that was useful because if you sort of started assigning a value to those and coding for them, you can then get a sense for the maturity, the average maturity of the standards in the different categories. And so network security is fairly mature. A lot of standards have been deployed, and at least according to this Nist government agency, they have conformity testing, they have some type of assessment process that represents, a pretty mature standard. But then there is less maturity in other sectors, cyber incident management for one, security automation for another. And so I modeled out this maturity score by drawing on their appendix. And I actually got different levels of maturity than they did in the report. And so I don't know, there might just be a qualitative difference here, but it's sort of an interesting question is, when I ran the math, I got something different than their table, but their table didn't explain the methodology for measuring maturity. So who's to say? But there was a comment period, and had I submitted during the comment period, maybe they would let me know. And so you see, that you can participate in this process. When the government releases these larger reports, they ask for public comments. Very few people cared about this report, even though it's the best landscape document on IoT standards released thus far. It came out in February. Comment period ended in April. No one really did anything about it until the last 2 days, and then all of these are mostly like IoT companies, or So these are corporate actors, not technologists. And you or I would be welcome to, read through these documents and provide our comments. I look forward to seeing the formal version. So as you sort of are tracking the IoT landscape, things I'm excited to do at this next stage is to sort of pull apart this distinction between protocols and security controls, and equating them might be problematic for how we understand the maturity of the IoT landscape. But then also sort of looking at these comparative SDOs, will national agencies like Nist guide this standards-based standards development, or will it be these non-commercial business consortiums and professional associations? I don't know. I dropped this tiny URL here. This has all my data, so if you want to check it out, you can sort of look at that. And feel free to reach out to me at Karl Grindal if you have your own thoughts or interested in collaborating on mapping out this IoT landscape space. All right, thanks.
All right, so I'm going to do some Econ 101 here, which I think is a change of pace for B-Sides, but let's go for it. The way economists strike to think of goods out there, or any material consumable by us out there, is that they're either rival or non-rival, excludable or non-excludable. And the internet is sort of a public good. I say sort of because for the most part, you don't deny access to the internet to people. Whoever can pay for it can log on, get a connection. And my usage of the internet doesn't bother your usage of the internet, sort of, unless you're on the same BSides Wi-Fi network. But the reason social scientists like to classify these things is because now I can say is that, you know, the problem you guys are worrying about, that the internet has a security problem and nobody's acting on it, well, Aristotle was worried about that too, and people have been talking about this for centuries. So this idea of who governs the commons, how do you figure out, you know, the guy upstream is probably releasing pollutants into the river, and you're fishing downstream and you have all this murky water. And somebody bought a router, never changed the default password, and now it's being used in a DDoS against you. So to frame this is that there's this action that is desperately required of somebody to take charge and say that, you know, this is how we fix it. But right now, the way incentives are organized is that for, at least in IoT, is that the mantra is cheap and fast, and it's not necessarily secure. Like, that's not the advertisement when you see a home security camera, or when you see, you know, one of the Roomba ads that software updated, patchability. It's usually, you know, fast, easy, clean, that sort of stuff. And so Ostrom, who won a Nobel Prize thinking about collective action and governing the commons, says that there are like these two things that need to happen before, you know, a community or a group of people will say that let's take action, let's govern these commons. And the first thing is that, you know, the new rules people come up with have to be better than the status quo. I think this is very 101. If you come up with a whole excellent system, but it doesn't work as well as the prevailing system, nobody's going to follow it. And two is that if you want collective action and you don't want, you know, top-down regulation, or you don't want siloed, fragmented spheres of IoT, it has to be collective. And for that, you would need participatory rule-making systems. So me, or anybody in this panel, or anybody in this room should be able to contribute and organize around that rule-making system. And how do you do that for IoT? Karim is going to talk about that.
All right, thanks, Ishan. So following directly from Ishan's train of thought, if we consider security as a sort of a public good, it seems evident from what we're seeing out there that it's being underprovided in the market. But at the same time, the security solution is going to come from industry and market stakeholders. That doesn't mean that it doesn't come without a slew of problems on its own, or that, you know, the NTIA or Nist aren't doing excellent work in that space already. So there are many proposals or like public policy IoT security frameworks out there already. You know, some people pontificate about cyber hygiene, and we're certainly guilty of that. But there's always a risk there of overemphasizing the compliance aspect of security instead of doing actual security. I don't know if you guys remember, some years ago there was a big issue with the PCI DSS standard. It was a case of perverse incentives, basically, where the quality assessors were doing security certification, but at the same time selling security consultancy for these people. So there was an obvious conflict of interest there. Senator Mark Warner from Virginia proposed this IoT build. There was a lot of pushback from industry. It died in its infancy. Also in 2014, I believe, there was a Supply Chain Transparency Act that suffered the same fate. And there's also a lot of certification schemes out there, but they also run the risk of overemphasizing a compliance over security aspect to it. So we don't want to end up with nothing here, but at the same time, something's got to give. So we were sort of thinking of potential IoT registries, and we're playing very fast and loose with the terminology here. I mean, we could debate what a registry should look like, but we were sort of thinking that it could be defined as any public or private naming system that securely identifies and stores descriptive device information. And I don't know if anybody recognizes this, but this was a recent proposal by the IETF, which is called the Manufacturer Usage Description Model. It uses, what I liked about it is that it uses a standardized Yang data modeling pattern here. So what we like to see is stuff like a namespace. This is a URN here, Uniform Resource Name, which is a persistent identifier. But this could also very well be an ARN, which is what AWS uses. We also like to see when the last update was sent, if the device is currently supported, and whether what the traffic from the gateway to the IoT device looks like. So this is sort of a breakdown of what the different trust systems that are out there. So in a hierarchical governance model, such as DNS and the ICANN regime, you can sort of seed trust from a root authority, say the root zone file, and then you distribute that through RIRs, registrars, etc., ISPs. But there's a central point of failure. On the flip side of the spectrum, when you have blockchain and Bitcoin, there's no central point of failure. So I will sort of be considering here the pros and cons of different registries, and I was sort of hoping to get a mesh between governance structures of registries and their technological characteristics to see how it could be deployed for IoT effectively. And if there's anybody that would like to talk to me about this afterwards, I would truly appreciate it. So this is very briefly what MUD looks like. As I mentioned before, we really like that it's a lightweight model that standardizes useful device information. It was recently picked up by Nist that are, I think, either forking or trying to deploy it in an enterprise IoT framework. They're adding a threat signaling server to it. There's also no hardware modifications needed to IoT devices, but on the flip side, the drawback is it doesn't fingerprint legacy devices, and that is a big issue. Also, the MUD file, which is a file that contains all the useful IoT device information, is just provided bona fide by the manufacturer. And unless you want to impose onerous regulations that stifle innovation, a lot of the smaller players are not really going to provide it because they just don't care. So I just included this to give you an idea of what other sorts of registries are out there. These are the classic competition going on right now between AWS and Azure, depending on how you want to pronounce it. But these two platforms basically are, they suffer from the same hierarchical trust mechanisms that the others do. So although they offer, different functionalities, they rely on a lot of the same open source code that a lot of the other platform use. They also have some of the same drawbacks. So blockchain, the big hype, right? So how can it solve IoT? So there was this very interesting new concept of a decentralized internet. I don't know if any of you watch Silicon Valley, but what we really like about this is that they propose a solution to something called Zoku's triangle, named after the creator of Zcash. So naming systems usually have a hard time combining these three properties in a system. Security and uniqueness, decentralized trust, and human readable or memorizable identifier. As you know, naming systems need to combine context and an object identifier to create an actual ID for an object or digital asset. So, to sum up here, some of the challenges, there's not really a space to collaborate. So you might have academics that create, proprietary databases for IoT. You might have private vendors that are just acting out of sheer rational self-interest because of, collective action problems. So we really need to formulate a good public policy framework, but the question is, how do we get there? There's a lot of challenges on the global front. There's a sort of, you don't hear a lot about this in the news, but there's a sort of a division, worldwide division between BRIC countries and the ITU, multilateral way of seeing the world, and the IETF and Internet Society on the other hand. I'm just mentioning in passing that Bob Kahn's digital object architecture, which is really the ITU's purview right now, is picking up a lot of ground in Russia and China. So this is basically our call to action for the IoT community, given that this is the I Am The Cavalry panel. This piece is about education, awareness. We really want to get the word out there. We don't want to be inviting onerous regulation, so we better come up with a multi-pronged solution. Thank you, and I'd like to go over details over a question, but I didn't want to run over time since I see that we're already 30 minutes now.
All right. Thank you. Have you tried turning it off and on again? So, we're going to wrap up by talking about something that is actually currently underway. And this is not a new idea, but I'm going to try to convince you of two things. One, that this is the time that we can actually make it work. And second, that this is something that is really helpful for trying to tackle some of the problems that Jessica laid out, of really understanding exactly where and how to prioritize our legacy concerns. So who's heard of software bill of materials? Who's heard of SBOM? Okay, so we'll do a very quick overview. This may come as a surprise to some of you, but software is not hewn out of alabaster marble by Greek sculptures with little halos over their head, right? It's assembled out of parts. And some of these are very carefully chosen after weighing options and going to conferences, and some of them are just ripped off whatever you could find on Stack Overflow. And the challenge is actually understanding how what we pick and put in our software affects the users of software. And there are many paths that when we look forward to figuring out how do we make sure that the devices and the software on those devices is better. There are many paths we have looking forward. But at very least, let's start with perhaps the lightest touch possible. Knowledge, transparency. How can you be against transparency, against having a little more information? A software bill of materials is a radical notion that says, hey, when you give me something with software on it, it's helpful to know what are the third-party components that are built, that are the building blocks of that software. Are you giving me vulnerable library version old.old, or are you giving me shiny new version new.new? Now, there are a bunch of benefits to this. Transparency has a delightful feature, which is often key in promoting better markets. You're someone who's buying software. There are two vendors out there. One of them is willing to show you what the components, what's their list of ingredients. The other person is selling you a bag of cookies and says, no, we don't want to tell you what the ingredients are, but trust us, it's okay. They're all natural, right? You're going to want to go with someone who has that confidence of transparency. In fact, I'll go you one further. If you have a good process for developing your software, for developing your product, pulling out this list of ingredients is pretty simple. It's actually something that works with a natural process. Heck, GitHub will do it for you automatically. So will Maven. There's an Eclipse plugin. If you don't have a good process, then it's a little harder. So going back to the Economics 101, this is what we call an efficient signal. It's something that if you look for in the marketplace, it can be an indicator of quality, even if it doesn't mean quality itself. So that gets to the purchasing side. Perhaps the area that we think about the most when we think about software bill of materials or software component transparency. I can't use the term software bill of materials for a couple of reasons. When we think about The value is this notion that, hey, the things that used to be secure yesterday may not be secure today. So I go to the store and I don't pay attention to ingredients. I just throw things into my cart and I put them on the shelf. And then Jessica comes over to join my family for dinner. And Jessica's deathly allergic to peanuts. Now, I can do two things. I can call up Nabisco and say, hey, I've got a box of this thing. It was made at this date. Are there peanuts in it? Or I could look at the goddamn list of ingredients. Right? This is why we have lists of ingredients. It's so that we can decentralize the risk decision making that come with consuming delicious, tasty treats. Surely we can ask for the same thing in the devices that make our lives richer, better, or in some cases, safer and longer. But Allan, you haven't gotten to the legacy question. How do we think about end of life? This is perhaps one of the things that I think has the most power. Because when we think about how long a device is going to last, we're drifting away from the cameras and the smart doorbells and the thing that feeds my dog and let me look at pictures of him when I'm traveling to Vegas. And we start drifting into the things that are keeping Granny alive and the things that are keeping the lights on. Right? The stuff that the cavalry is here to really focus on. These are things with very long lifespans. They're technology hooked up to either really big pieces of steel or very well-engineered pieces of steel. It's all steel, I think. It's possible they make devices and cars out of other things these days. I'm not a material engineer. I'm on the software side. So, underneath the hood, we're dependent on all of these components. If you care about the resiliency of your organization, knowing those details is very helpful. Who's heard of LeftPad? So, LeftPad, delightful example of software supply chain. It was one of the simplest functions that you could ever imagine, right? Take an array, fill it with zeros that way. Sorry, you're facing me. That way. So, right, pad it to the left. Now, turns out there are lots of lazy programmers out there who say, fuck it, why should I write code when it's there? That's how we write code, right? We reuse other people's libraries. Code reuse 101 for using software. So it was used in a whole bunch of great projects in the Node ecosystem. Until one day, and I won't get into the story, but essentially the guy who wrote it, who had a different software package, was offended. They made a decision he didn't like. He took his bat and balls and went home. So that meant every piece of software that used LeftPad was calling a function that they couldn't dynamically link to. Or rather, was calling a function that linked to a function that linked to a function that linked to a function that they could no longer dynamically link to. Whoops, we broke Node. So these are the things that when we're caring about what is the long-term stability, make a real difference. When the community that's maintaining a particular project says, we're no longer going to support single threading, right? All of the cool new GPUs that are driving our particular project are multi-threading. It's a pain in my ass to support single threading. Well, that dam is hooked up to a couple of chips that I can't really take out right now, and they don't support multi-threading. So what do? Having that visibility into your system is the ingredients that allows us to start thinking more strategically about when we're going to have to make certain product replacement decisions. These are not things that are cheap, right? The difference between stuff and web is when you make a mistake in a web platform, it's just, hey, let's commit a change. When it's stuff, it involves budget and politics and meetings with people like me and Jessica. And no one wants that. So how do we plan forward? One of the keys is going to be having this level of transparency. Now, just a very brief plug for the work we're doing at NTIA. The Cavalry is actively involved, but we need support from you if you're interested. There's a very particular discussion in this initiative. It's open. It's our multi-stakeholder process, right? It is open. It is transparent, focused on saying, what is a software bill of materials and how can we all do it in a similar enough way so that there isn't unique solutions for healthcare and energy and auto and, oh, by the way, the software industry. Let's try to find a shared way of doing it that meets all of our needs. There is a particular working group that is focused on the healthcare sector. If you're interested in this, it's time to get involved. The auto sector has expressed some interest in doing this. Imagine you're a car manufacturer. Wouldn't it be really nice to know what's in some of the software that you're folding into the electronics that you're shipping in your cars? Because under American law, you're liable for everything that's in your car. So it'd be really nice to have some assurance that it was, new, fresh software. There are lots of hurdles here. How do we use this information to the best advantage? But we're going to tackle those as we understand what transparency looks like. So that is my call to action, which is, hey, get involved. Now I think we're going to have a broader discussion. So this is your chance to dive in, ask questions of Jessica, who can tell you about life on the Hill and how to get involved, the Georgia Tech team, which is doing some great research, and maybe able to share some insight into perhaps what the academic world is like if you're interested in engaging in that side on IoT. Just remember, share questions, share your new ideas. There are no dumb questions. There are a shit ton of bad ideas, but that's okay. We won't judge. All right. Do we have a volunteer who can help with the roving mic? Hey, there's a guy in an orange shirt. We got Pete in the back.
Thanks all. It's a slight looking at the challenge and the complexity of what you're trying to do, which is great and amazing. Is there a challenge in trying to find the perfect solution due to the complexity of the challenge? And actually, how long will it take to find a perfect solution? Can we get close to a 90% solution or a 95% solution and then go for it? Or do you think there is a 100% solution for this across the whole industry, across all the legislation, the whole lot? Can we get there? Or are we going to have to go for something slightly shorter than that and do it quicker?
Are you asking this panel's opinion? Is the challenge all of IoT security?
Yeah, well, software bill of materials, rolling it out, the international impacts of that, the whole lot. It's a big challenge and a big problem space. Finding the perfect solution is going to be really, really difficult across all the different stakeholders. So will we get there? And if we're not going to get there, what does the 90% solution look like?
All right, tell me if this. Oh, it is working. Okay, great. I'll take that first. I think as trite and as cliched as the saying can sometimes be, don't let the perfect be the enemy of the good, but I think that's going to be the key here in software bill of materials. We started having this conversation over a year ago when it was introduced in a big government healthcare report called the Healthcare Industry Task Force Report. And one of the biggest roadblocks we initially ran into when we started having this conversation was folks saying, like, look, this is so complicated. It is going to take us so long. We're never going to be able to figure it out. Nobody's ever going to be able to agree on how we should do this. And so we should just forget about it. And I think our response on SBOM was, that's not acceptable. That's, being that defeatist about it isn't helpful. We can get there if we try. And so we sort of demanded that the healthcare sector figure it out. We used the power of the congressional letter to essentially tell the Department of Health and Human Services that they didn't have a choice about it anymore, that they were going to be figuring out how to do software bill of materials. And we looked very much forward to figuring out how they were going to do it. So I think at least from the congressional perspective, especially trying to be as non-regulatory and collaborative with the industries that we're trying to ultimately help as possible, I think our answer is, look, we from the energy and commerce side understand that this is complicated, understand that there's a lot that has to go into this, but the imperative for doing it, the I Am The Cavalry tagline that Bits and Bytes have met flesh and blood, this is so critically important that you guys are all going to sit down, you're going to figure it out, and we'll see you when you do. So I don't know if Allan has any other better thoughts, but
so who does operational security for an organization? Anyone on the front line of their organization? All right. How many of you guys used advanced threat intelligence services? At least 2 or 3 different products, 3 different feeds. All right. It's a pretty rich industry, and yet we still have companies that only use one source of threat intel. My God, don't they care about the children? We have to acknowledge that there is a maturity model that we have to, say, hey, there are going to be some folks that are going to be cutting edge that can use this data today. That's the leading edge. What we did at NTIA is we didn't frame it around the government has to do it. We framed this as a market issue. We have supply and demand. So we brought together vendors, software vendors, medical device vendors, industrial control system vendors, and then we put their customers in the room too. The people who buy their products. We brought in banks, hospitals, energy companies, and all of a sudden, it stopped being quite so impossible, and it started being well, what would this actually look like? We went from the why to the how. And I'll be honest, I am very skeptical that there are more than a dozen hospitals in America today that could actually use the bill of materials. I'm perfectly willing to be told that I'm wrong by the many experts in this room. But we've got that first dozen. They're raring to go. And one of our goals is to make it machine readable so that we can fold this into products. And we've also worked very hard to make sure that the vulnerability management tool providers could be in the room. Right? At the end of the day, the path towards maturity involves automating, folding it into existing products. So you start small, you start making it something that's nice, and then it starts being something that's commonly asked for, and then it becomes a default package, and then maybe, if those bastards up on the hill want to regulate, we'll let them. Further thoughts?
So, Allan, you mentioned one industry where the end user for this information, I think, is very well defined, and that'd be more the industrial control system space, where the end users of the technology are large industrial concerns with usually technology teams who might understand a software bill of materials. How do you model this in more like automotive and medical space, where the end users are consumers at large? Especially when you get into, say, like personal medical devices or implantable medical devices and automobiles, where you have consumers that aren't necessarily technically inclined. What should they do with that information if it's available?
That is a fantastic question, and I think you're dead on. This is not consumer-grade information. I'm going to speak in my personal view now. This is not the view of the United States Department of Commerce or NTIA. I don't believe that the path towards better security relies on empowering consumers. We've been trying it in 20 years. That's not true. 17 years that the field of usable security has existed. This is as an academic and policy research priority. We have successfully taught the American consumer to do one thing. And what have we taught consumers to learn? We've taught them to look for the little lock icon. We taught them, and they finally learned that lesson exactly as Let's Encrypt pushed to make sure that every single goddamn website, whether it was legitimate or not, whether it was malicious or not, had transport layer security. So now it's a meaningless signal, right? That is our one victory we have. It turns out not terribly useful. So we definitely want to push on what the enterprise is, where the folks who care about it. Let's go back to the broader IT thing. I don't want to focus this on bill of materials because I think this is true. I want to also give a shout out to another project that many of the room worked on through NTIA, which is patching, right? It is one thing to say, hey, you're buying a TV, you should make sure that it's patchable. And that patchability should, include some understanding of how long software updates are going to be available. And also, the update process itself should be secure. After all, a patching mechanism is a remote code exploit that you really hope only one party can use, right? So right? Patching is an incredibly dangerous attack surface. Now, I may not be able to do this, and I'm, not the most technical guy in the world, but, I've been doing this for a while. Who stayed in a hotel room last night? Who is absolutely confident that the TV in the room was not turned on and listening to you? Today, the hotels have a very strong interest in making sure that if there is a security flaw on the things that they have in 10,000 hotel rooms, they can fix it quickly. We need to empower them, because these aren't experts, right? Again, these are still people who buy TVs for a living, not security experts. We need to focus on how to empower those people to ask the right questions. So that was a long way of saying we're going to go with where the levers are. The auto industry is a great example where the end consumer may not be able to use the data today, but the auto manufacturers would love this data today. And so let's promote it and put it in their hands. What happens to it tomorrow, we'll figure out. That's between them and their regulator. Right, Doug?
Who do you want?
Oh, yeah.
I was just going to add that in the registry space, you can think that there are naming conventions that are known by consumers. IP addresses are kind of known. But a lot of them, if you asked the average person for their computer's MAC address, they would have no idea how to find it. If you think about the IoT, in the IoT standard space, certain ones like Bluetooth or Wi-Fi have been trademarked or branded in a way that consumers can wrap their minds around. But an IEEE or an IETF standard is not something that a consumer would understand. And so even if the consumers can still benefit from both standards and registry-based naming conventions that they might not have to interact with.
So I think we have time for one more question. Oh, sorry, can I get one right of reply from a gentleman from the auto sector, and then we'll get one more question. Thank you.
Okay, well, I was going to ask a question. I was also going to point out that some vehicles today are actually made with aluminum, so not just steel. But if you look at the software that's in vehicles today, oftentimes that software was developed 5, 6, 7 years ago. The car I drive today was built around Windows Vista time, and the software was probably developed at Windows 98 time. So Microsoft is not expected to keep Windows 98 up to date now. How do we do that with IoT products that are going to be used by consumers for 15, 20, 25 years?
I think from what I have seen of both the legacy technology conversation around the RFI and the software bill of materials conversation that we are starting to have, I think it's not that we know the answer to that. That was something that came up in the RFI quite a bit. I think there was one group actually who came out and said that it was their opinion that if there's a medical device, for example, that's still in a hospital, then that manufacturer should just have to support it. It doesn't matter how old it is. I think our point was that that's pretty infeasible, and that's really going to stifle a lot of innovation and technological growth. I don't have a good answer for you, unfortunately. I think one of the ways that we're hoping that software bill of materials really affects the ecosystem is that it eventually becomes too publicly embarrassing to put out old software, that people find ways to get that stuff. As we continue to cycle legacy devices out, hopefully, that it becomes sort of too embarrassing to start putting old stuff into the system, into the ecosystem on a newer basis, and so that this problem almost becomes self-correcting as time goes on.
Georgia Tech, any last thoughts?
Actually, if we have a little more time here, I just wanted to go back. Can you hear me?
We don't.
We got the stop now. 30 seconds.
This thing is on.
Just talking.
All right. Just wanted to go back to the S-bomb train of thought here. So we don't really hear a lot. This is just for the sake of hearing both sides of the argument here. We don't hear a lot from the manufacturer's perspective, and their reluctance to really implement SBOM. What would you say, Alan, would be like the top 3 ways to address their concerns, and like how would they perceive this as really onerous and stringent imposition on behalf of government?
So I'm getting penalty time. So first, just make it clear, we are not interested in regulation at the moment. There are others who want to. But the second is context. Vulnerability may not mean exploitability, and so we need to find a way to communicate that. But I think we are now well past our time by at least a minute, thanks to the grimace of the gentleman in the orange shirt. So I want you to hopefully thank the Georgia Tech team and Jessica.